So I think before we dive in to where we left off last time, were there any questions around the assignments?
I guess I had a problem with identifying type 1 and 2, but yeah, I don't know, I think I was just thinking the wrong way about it, I guess. Like, I think I've got a bit of a backwards approach to things.
So I guess again, sort of the type 1 error is sort of incorrectly rejecting the null hypothesis, and that's sort of the risk of doing that is basically the alpha level you set. So those either 5% or at which level you set, that's the risk of conducting this type 1 error, and that's sort of rejecting the null hypothesis when it in fact would be the case. And the other way around for the type 2 error. So that was for the first assignment. Were there any more questions? First assignment, second assignment?
There were a couple of, I think it was scenarios in the second question, which I just thought were a little bit ambiguous, and it did seem to corroborate that intuition from the book when it said that research scientists will argue back and forth between different methodologies because all things being equal, they both have their advantages and disadvantages. And so, because of that, I assumed that in those cases there wasn't so much a correct answer as a well-reasoned answer.
Well, again, yeah, well, you'll find that quite often. It's not like it's let's put it that way, a hard science like maths, where sort of where there's always most likely correct answer, I guess. It's as you said, you will find people arguing over points. It's like where they would say like, well, there's probably more reason for another approach or for this and that approach. Again, I think at the end, in your report, well, the final thing you want to do with your study or with your results, you want to report it some way. You don't just have it sit on your computer or in your cupboard. You want to report it somewhere to an audience. That's one of the reasons why you do your research in the end. Might it be a thesis, a journal paper, a conference presentation, or a tech report, or whatever it might be. I guess there, it's up to you then to make a point for your approach and why you took this approach and why you believe that's sort of the best approach for taking that. And what most of the time happens, there's other people reviewing your work, and happens quite often that reviewers have different opinions, and then that's sort of the way current research, the current research environment works. You present your results, or your work is reviewed by other people, and sometimes they don't agree with your approach, and then it's a matter of either adapting if it makes sense, and if it's like, okay, well, that's basically good feedback, and then you probably can try to incorporate that feedback and adapt your approach. Or the other way around, if you believe the reviews don't make too much sense, you can try to make an effort to explain your approach and your points sort of in more depth. Sometimes you have the chance of a rebuttal. You don't have it all the time, but sometimes you do, and then where you can sort of answer to the reviewers' concerns. Okay, so any more questions? Should we go through the question of the second assignment or not? Well, should we? Should we go through them? Okay, just very quickly. Yeah. So the first point was read the following scenarios and identify actions and conditions that may induce systematic errors in each scenario, and explain the direction of the impact, whether the observed data will be pulled up or down from the actual value. So the scenario 1 is an experiment that investigates how novice users learn to use the T9 method to enter data into a PDA. And a participant has actually used the T9 methods over a year. So what potential error could...
Bias caused by participants.
Mm-hmm. And so what would most likely happen?
Well, depending on what your interpretation of what the effect is, but I guess it would pull down the results, but it would ultimately make the reaction speed faster, which will mean...
Well, when you say pull down the results,
that's the ambiguity. It's not actually, well, in that term, that's actually pulling up the results.
Mm-hmm.
But in the reaction time thing, it's actually reducing the speed. So
So I guess, well, in the end, what could you measure in an experiment like that? You said the reaction speed, or reaction to what would that be?
So the speed at which one learns the system. I don't know.
Or input speed. Or
input speed. Yeah.
I guess reaction speed is not the right one. It's input speed or task completion time.
Task completion time, for example, like that. It could be learning how to do it, I guess.
You understand all of the techniques, basically.
Mm-hmm.
All of them, good knowledge of them.
So and most likely someone who has already experience with that would be, well, I guess faster than a novice, most likely.
Mm-hmm.
So in that case, it would, as you could say, pull them the time. It would pull the time down. Well, most obviously, it will produce an outlier. So you will have a mean of sort of the novices, and there would be one data point that's sort of somewhere way off, well, most likely way off the mean somehow, it's just a lot faster. It certainly will skew the results. And in the end, that's one of the reasons, and we'll come to that, I think, next time, to always have a look at your data first. So if you do your analysis, just don't dive right into the analysis right away. Just always have a look at your data. Just make printouts, plot graphs, whatever, to have a look at the data and to see if there's potential outliers. And how to deal with outliers, we'll discuss that next time in more detail. Just probably another scenario, sort of the scenario 2, an experiment is introducing website to a participant. The experiment says, my team has spent 6 months on this site. The site is like our baby. Well, what happens? What could happen there?
So we'll introduce some experimental bias, because he'll be dictating probably over the shoulder of the participants about what to do almost, and just be commenting and probably saying things you shouldn't be saying.
Mm-hmm. Well, yeah,
influence the participants.
That certainly could happen. If you really like your design or your sort of in your interface, you can, exactly, that could happen. That you sort of try to.
You're asked misleading questions as well.
Mm-hmm. And if it's just this, this the only basically statement you say, you don't keep on sort of making ongoing sort of statements. Just with this statement, what could happen after that? Or how could just this statement influence the results?
Well, it's basically making the participant biased towards the way they're going to rate the site, so they're going to rate it more highly than not. It's going to influence that.
Yeah, that could be the case, definitely. That they say those guys put so much effort in it, and I probably would. I just don't want to. Yeah, exactly. So I'm just going. Okay, it's not that bad. Exactly. So it can sort of produce a social desirable answer, I guess. Okay, let's have a quick look at the second question. So the following scenarios: discuss the type of experiment design between group, within group, split plots that is appropriate for each scenario. So and you say it's sort of it's a little bit ambiguous sometimes.
Some more than others, yeah.
So which one you thought was most ambiguous?
Let's see which one has the most writing in it.
3 and 4.
4.
Okay.
Yeah.
Ah, yeah, the online agent, that was sort of a little bit interesting.
Yeah, I also be interested in 2.
Okay, let's have a look at sort of probably at 2, you said. So a research team examines the effectiveness of joysticks and trackballs for selecting static targets and moving targets.
So the way I did it, I was divided it into the independent variables. So I think there's 2 independent variables. One of them is input device, and the other is target status, whether moving or static. Yeah. And because there's 2 of them, it's factorial design. And then I weighed up the pros and cons of using between or within, and found that actually a good compromise would be a split plot.
So what's the advantage of a split plot over another design from point of view?
Well, it means that I can reduce my sample size in comparison to a between group study slightly, but also I can focus on the variables that I think I'm most interested in. Yeah.
So which way did you go with each?
So let's see here. I think I...
So you can use it between.
So each participant would only be exposed to one input device, but would also be exposed to both moving targets and static targets. So the way I was kind of concerned was about so learning bias, and so I thought if I arranged it that way, that is, they're not getting used to the task on the screen of these moving objects, because it's possible that the moving objects might be kind of the same each time it's run. So if I just do that part, they one static selection task and one moving selection task, and then have just one type of input device for that, because I thought, well, some people might get used to a joystick and trackball, and there might be some bias between that. So,
And as you said, it's possibly not one correct answer. So did you? How did you come up, or with what designs did you come up, for example?
Well, I've got my answers on the other computer. But yeah, I mean, I just talked about the trade-off between greater sample size and greater independence of the analysis, and that in the right words. But yeah, I mean, generally, I don't see any reason to use a between group method unless you're concerned with how long the experiment's going to take. And that didn't seem like that.
And I guess, yeah, exactly. So you can make sort of arguments for, well, I guess for each setup to some extent. It can be, well, you could have concerns about, as you said, sort of learning effects potentially.
And individual differences was another one.
Well, within design, you sort of control the individual difference a little bit better. So for tracking moving targets or non-moving targets on a screen, it's some probably could argue, well, there's not so much learning effect. Others would probably say, well, there could be. So I think you could, in the end, go both ways. You could sort of have them as a within subjects factor or a between. So I guess basically comes, it's I guess up to you and sort of how you sort of argue your sort of.
The individual preference, or whatever you call it, the ability of each individual person, the reason to use between group analysis. How does that affect your actual results, and wouldn't it be an unbiased error? Do you know what I'm saying?
So to say it again.
So when you use a between group method, you run 2 tests over a single person, and you can compare. Between
the other way around.
And how does that affect the actual results of your experiment, the actual data, in terms of counteracting? One person might be a complete guru, or one person might be not very competent. How does that minimize the effects, the bias of
if you run it as a within subjects design.
Yeah.
Because well, the difference between the participants doesn't have such an effect on the results, because you could sort of expect that a novice, would produce sort of poor results with both interfaces, most likely.
Would you say
poor results with just in general,
Yeah.
and an expert would produce better results in general. So what you're interested in, not the difference between the people, because that's what you're not analyzing the difference between your participants. You're only analyzing the difference between how they did on the first, well, with one interface and with the other. So you're just interested in the variability within within the participants, but not between. And that's sort of one of the differences that sort of that comes into effect,
Well, I don't understand it, but that's the sort of thing that you're trying to eliminate when you choose a sample size that's greater than 2 or 3. Is biased by having a specific distribution of people.
Sure, it definitely do, but sometimes, well, if it works out pretty well, that you have sort of a similar, well, pretty similar groups in terms of your variable, like prior experience, then the between subjects design can work quite well. But it's sort of the within just controls it a little bit better to some extent.
Yeah, I think I see what you're saying. So it actually can allow you to have an even smaller sample size.
Yeah,
Substantially smaller.
Exactly. Yeah. That's one of the advantages of the within subjects design, and that's one of the reasons why it's sort of used quite often in HCI as well, because sometimes it can be hard to to find participants for certain studies, and we're going to talk about this today, sort of in the when we finish with the first sort of lot of slides. We're going to talk about sort of more the participants and recruiting participants and how to deal with participants, and we're going to talk about sort of those issues, how to recruit participants for HCI studies as well.
For that particular scenario, I think you wouldn't want any. You probably not want novices, basically, because you're not really comparing the learning aspect, like all the learning effects. You want to know if this interface is actually better than this interface. You don't want to know if this person learns this one better than this person learning this one better. Doesn't mean that this interface is better than that one. It just means it's better learner, like easier to learn.
I guess well, that's a fair point. It's not for each. Well, you not always need a sort of an even or just a general sample that sort of reflects the general population. Sometimes you want to get you want to get rid of sort of those learning effects, and then it just makes more sense to recruit experts. But that's again something you have to think about for. Does it make sense? So which population does make sense for my experiment? And sometimes, yeah, definitely it can make sense to recruit experts and not novices, especially to get rid of sort of some potential sort of learning effects, or sort of just as a stepping stone, where they say like, okay, well, yeah, you would have to have such a huge, such a long introductory phase to get them up to speed. That just wouldn't be feasible, and then it can certainly make sense to recruit experts. You just have to be aware then how you interpret the results and how you generalize the results afterwards. Then but you can't generalize it to the general public. Then you can't say, okay, we found that this this result it potentially doesn't generalize to novices. Then
So
you just have to be aware of those consequences then as well.
So in that case, I actually said I think within groups will be better, but as long as there's sufficient training time for each task, so that the learning effects are minimised. So if an expert does start using this trial period, if he's already smart at it or whatever, it's not really going to benefit him that much. But if there's a novice, this training period will probably bring him up closer to speed to the expert, getting better results basically. Yeah.
Cool. So just if we continue from where we stopped last time, we just talked about sort of the general, well, it's called the life cycle of the experiment, or sort of a run through sort of what how sort of your research could sort of progress through different stages. So we say, first you start off with identifying your research topic, so your research question. You start to come up with some hypotheses. You then design your study, your experiment, to find an answer to those, well, to your research question and to test your hypotheses. Ideally, well, you run a pilot test, a pilot study to test everything out. Your design and that everything works as expected.
How often does that actually happen?
It does.
Oh, really? No,
Yeah, it does.
This book was a little bit more skeptical.
Well,
of running
it's
pilot tests. When you have the luxury.
well,
More about money than anything else.
well, but money and time, I guess, but well, just my experience here within the lab. Well, sometimes it depends on, well, exactly. Well, mostly time here, not so much. Well, money could be as well, but I think it's in your own interest to run a pilot study. It doesn't have to be a huge, study. It's a pilot, so you just want to test everything, and it does happen. Not always, but it certainly does. And what should not happen? You just run a pilot study and take this as an excuse for not recruiting a big enough sample, because that happens quite often. People they do a study with let's say 10 participants overall. They say like, our pilot study found non-conclusive results, but we tried to blah blah blah. So it's not a publishable result in the end. It's a pilot study. It sort of serves to inform your future sort of, or your sort of further developments in your bigger study.
I don't think you can use really the results from a pilot study because there's too many ambiguities or like biases that can occur. And those are the things you're trying to eliminate by doing the pilot study. So
Exactly. But well, unfortunately, it happens quite often that again, due to time constraints or its upcoming deadline for a conference, and you really want to get into this conference, like, okay, let's just publish the pilot results.
You just did that.
But no, we didn't do a pilot. We did a pilot study, and then we did a kind of real study of our pilot study. So,
okay, so after that, you recruit your participants, you run your actual study, and you collect your data, you analyze the results, and then you report it wherever you see fit for your results. So when you run your experiment, in your study, just make sure that sort of everything works, beforehand. Just make sure your data gets. If you, for example, use a computer to do sort of data logging, whatever, just make sure that everything gets logged, because that happened, not just once, to me and to other people, that you run your first participants, after the second or third participants, and you find like, data didn't get, either there's a bug in your logging, in your data logging, so it doesn't get collected at all, or there's a problem with the data collection that doesn't get logged correctly. Well, in the end, it means you wasted your time and your participants' time, and that's not what should happen. Make sure that all your materials are printed beforehand, and that happens quite often as well. You want to get going, you invite your first participants, they knock on your door, you want to get going, then it's like, sorry, I have to print my questionnaire, just can you wait a second, So make sure that your questionnaires, your consent forms, your everything that you need, and your sort of cheat sheet for your experimental cheat sheet, or basically your sort of log you use for running the experiment, sort of everything sort of is in order before the participants arrive. Participants arrive, you greet the participants, you introduce yourself and what you're doing and the purpose of the study. Don't try to be too specific. Well, specific enough that they can get an understanding of what the study entails, but don't try to sort of introduce early biases at this stage as well. So you just explain what it's about, but not, I guess, not what you expect from what results you would expect from the study.
Pretty much, I don't know, research into using like Turing machines, if it's Turing machine tests at a scenario for introducing subjects to scenarios and things like that. What I mean by that is there's no actual interaction or face-to-face interaction between the experimenter and the participant. Instead, there's like a computer terminal between them, and one of them just says, you know, a few words to the other and back and forth.
Well, no, I guess there's pros and cons to sort of this approach as well. You know, it's I wouldn't sort of subscribe to that it's necessary all the time, every time that you can have to get completely rid of the experimenter. Well, you know, I guess, you know, you could find pros and cons for those approaches. I wouldn't probably say that it's necessary. You know, just try to be as unbiased as possible. You know, just to reflect on how you sort of behave in front of the participant as well.
I just think that, like, from a sociological perspective, you can have just even your gender, which you can't do anything about, can have an influence on the participants. You know?
Yeah, but you know, it could even the using having the participants use a computer terminal could have an influence. They say like,
Sure.
"Oh, I wasn't expecting that." You know, wow, that's so impersonal. You know, and they just get, you know, frustrated beforehand. So, you know, I think though there's no sort of one perfect way of doing it. Just try to be as sort of as considerate and fair as possible.
What's the New Zealand Code of Ethics regarding deceit about introducing your experiment?
We're talking about this afterwards, about when we're talking about a little bit more about sort of participants, and yeah, your background is psychology, so that's a lot more common in psychology than in HCI research. But no, it is. It's not, no, it's not necessarily a bad thing. No, but you know, it's. We're talking about sort of the human ethics and sort of the human ethics committee as well, and how you sort of have to go through consent through the human ethics committee. We're talking about this sort of afterwards.
So there's things like in HCI, like take the glasses that invert your vision thing, so you perceive the world as upside down, and then your brain corrects it so it now looks normal, and then as soon as you take it off. There
have been experiments around that sort of, especially what was his name? Man, who just did this experiments on himself. But what you were talking about is more
information hiding.
Well, no, you set up a study where you don't tell the participant the real purpose of the study, in order to basically not pre-bias them to sort of produce certain results. Well, I will talk about some one example then afterwards to make that clearer. So you use sort of you're deceiving sort of the participant sort of for the sort of purpose of your study, and sort of it has sort of some ethical potential problems through, you know.
So I did a study like that, and I thought it was this thing, and then it turned out to not be that at all.
Mm-hmm.
And I felt really deceived.
Yeah.
And then I didn't want to do any more of those experiments.
Yeah,
so
yeah.
That was it.
Fair enough. Yeah. We're going to talk about this again, sort of afterwards. So again, get consent of your participants. We're going to talk about this in more detail as well, and assign your participants to your conditions and so on. So just as it goes on, so participants complete a task. Well, probably first a training, then sometimes it's necessary for them to get some training for your sort of new interaction technique for your interface. They complete the task. They answer questionnaires if you have any questionnaires in there. Sometimes you have an interview as well, and what can happen, that doesn't happen that often, sort of debriefing sessions where the participants has sort of a chance to ask questions as well. And you debrief. It's especially necessary if you do sort of studies like we were talking about. If you're deceiving sort of the participants, it's really necessary to have a debriefing session. And sometimes just think about if it's sort of a necessary step as well for your research, to have a debriefing, and sort of sometimes can be quite a nice thing to do. And sort of any compensation if you plan to compensate your participant for participating in the study, you do that there as well. Again, try sort of during your experiment, try to offload your brain as much as possible. So to write down the instructions, as we said, that on the one hand you can be consistent over your participants with instructions, very important, and it also helps you to not to have to think about sort of how do I just write everything down make a checklist, write down the wording you're going to use, that it can be consistent over all sort of your sessions. And print everything well in advance. Think about, do you need any assistance, probably for video recording, for taking notes, because sometimes it's quite important to take notes or observations during an experiment, and when you have to run the experiment, it's not always possible that you do everything on your own. So then it can be quite a good idea to have an assistant to make some notes, or just record it and sort of be the video editor during your experiment.
You can use observations in your documents as well. Is that right? Like just as general comments.
Definitely,
Yeah.
And it's we talked about sort of triangulation of results, and from my point of view, it's always a good idea to use multiple data sources to just make a stronger argument. It's not that you only use your task and task completion time to find an answer. You can use task completion time, and in addition, probably a questionnaire, interview, and potentially observation, just to get sort of information from multiple sources. Just get some richer results. But just be aware of which data collection method allows you to make, what kind of arguments afterwards, and sort of because from your observations you can gain different insights compared to your compared to a questionnaire, or from your sort of from your collected data. And again, double check that everything gets recorded and you actually collect your data as you intended to. Also, take pictures of your setup. So first without the participants, that's always a good idea to have sort of pictures of your setup afterwards for a publication. If you want to show the setup, it just makes it easier for a reader and for a reviewer to make sense of your setup if you can include a picture. So just think about that. Take as many pictures as possible. If you want to take pictures of your participants in action, you have to be careful, and you have to first ask them if you're allowed to do that, and you have to just ask for their consent to take pictures, to take videos if you want, and you have to make clear to the participant as well how you're going to use the pictures or the videos afterwards. So if you're just going to use it for your data analysis, just make clear that it's just for data analysis. If you want to use the pictures afterwards for any kind of publication, you have to make this clear as well, and they have to sort of give consent for that as well. So it shouldn't happen that you just take pictures during your studies, include the pictures in a publication, and then the participant basically gets sort of upset and potentially could sue you, I guess.
I don't know if they can these days.
Even if they can't, it's just not what you should do, I guess. Just be considerate to some extent.
Everyone's taking photos of everyone these days.
Yeah, but in the end, it's just not what you should do. You're asking participants to participate in your study, and you should treat them well and with respect, exactly. And so it's just a matter of you probably wouldn't appreciate someone just taking pictures and using them in any fashion they want. It's just as you said, it's a matter of respect of the other person. And sort of just try to be nice, treat them well. You can even think about sort of having a sort of some lollies that they can chew after they're finished. And it just, again, they're participating in your study, so treat them well, treat them with respect. And, well, allow them to take breaks as well in between. So just a quick sort of overview of what I would sort of advise you to look out for when you're sort of writing or reading some of sort of those papers that sort of focus on the evaluation. Again, one of the most important points, just check if they talk about sort of the research question hypothesis, if they include any hypothesis in their paper. Very important. Check for that. Check if the methods, materials, and everything they use and the participants they use, are described properly. So that only if the paper really goes sort of describes those items, but only if you get a good idea about those items, only that allows you to make sort of a good decision or just make up your mind if what the author is writing about makes sense or not. If the author doesn't sort of explain the method in detail or sort of what kind of participants they used, you can't really make sort of an informed decision if what you read here basically makes sense or not. So just check for those items. In the results section, sort of what I sort of do, I just sometimes can get picky and just go look for small things as well. So did sort of the authors, for example, set the alpha level, or are they just very but do they sometimes they tend to change afterwards, as they see fit, and that shouldn't happen. But sometimes you find that, and this sort of just check for those things. So check if the methods they used are appropriate for the research question, and the analysis steps they used are appropriate as well to find an answer to those questions. Check if sort of the results are reported appropriately. We're going to talk about this in the lectures about sort of statistics, then as well how to report the results in your statistics. And sort of in the discussion, just check if sometimes authors get quite enthusiastic and tend to sort of then oversell what they found, because sometimes what happens, authors didn't find a significant result, but it sort of was sort of almost somewhere there. Just there was a trend, and well, that's fair enough. They can say, okay, we didn't find a significant result, but blah blah blah. There was a trend. Well, there's sort of discussions. Are you allowed to do that? Anyhow, but what sometimes happens then in the discussion, this trend almost sort of converts into a result, and that's sort of what shouldn't happen. So check for those things as well. You shouldn't try to oversell stuff just for sort of keeping up appearances, I guess. So just see if the discussion is sort of consistent with the results then as well. Okay, just to go quickly through some of those considerations about sort of evaluating emerging technologies, and we won't have too much time to go into depth with those questions, but as I said, this is sort of, if you read this book chapter I sort of put on the learning environment, it's basically most of the stuff that's in there. It's sort of what we're going to talk about here. So we just go very quickly through those items. And if you want to sort of learn a little bit more and read a little bit more in depth, then just read this this book chapter. So there are certain challenges, I guess, if you want to evaluate sort of emerging technologies compared to, let's say, more standard computer interfaces or more sort of, commonly used computer interfaces. HCI, as you sort of probably read in the book as well, sort of has a long history. It's just and most of the evaluation approaches commonly used grew sort of out of this history, I guess, and sort of most of the evaluation approaches, if you look, for example, at usability evaluation approaches and all those usability heuristics you can use. We're going to talk about usability evaluation, I think, well, not next time, but sort of along in 2 or 3 lectures ahead. So a lot of those heuristics or guidelines for interface design are sort of applicable to most more common computer interfaces, like WIMP, like Windows icons, menus, pointed paradigm interfaces, and they're not necessarily always applicable for more emerging technologies. Like in our case, I was as an example to talk about sort of augmented reality. But some of the ideas about sort of icon size and those type of things are not necessarily one-to-one applicable to augmented reality interfaces. Because, well, in the end, sort of what is an augmented reality interface? That's the idea of the question. There's so many kinds of different input-output devices, screen sizes. You can deal with sort of desktop augmented reality. You can deal with handheld augmented reality. You can you can have augmented reality on tablets and sort of or sort of head-mounted displays. So you have sort of a huge variety of potential interfaces that all sort of come together in sort of what you say, the augmented reality interfaces. So there's not one size fits all design guidelines or heuristics. So there's again sort of certain challenges, I guess, that have to be considered when you want to evaluate those sort of new types of computer interfaces. You sometimes sort of step into sort of a new area, into a new land, sort of, and have to explore sort of, okay, what can I do here? Well, there's not so many experts, I guess, that you could use for expert evaluation of your interface, compared to if you're designing web interfaces. There's a lot more experts on web interface design than on augmented reality interface design. So they don't have that many experts. You have a lot of one-off prototypes compared to other interfaces, and you see it, well, because augmented reality interfaces or emerging technologies are most of the time developed in research labs, and research labs are not necessarily interested in developing end consumer products, but more sort of doing research. So you get a lot of one-off prototypes, sort of proof of concepts, and using those one-off prototypes to derive sort of common design guidelines or heuristics. It's sort of a little bit, well, not so straightforward or more difficult, because you have sort of different kinds of interfaces, and you can't sort of learn from sort of iterative design, because it's not designed as an iterative prototype. So yeah, as you see here, all kinds of different interfaces. So what would be sort of a set of common design guidelines that would sort of serve all those types of different interface implementations? So again, think about those things. Well, are traditional methods suitable? Well, to some extent, yes. If you as what we're talking about, sort of, measuring task completion times, measuring error rates. Now that's sort of applicable as well. You can do this with standard computer interface. You can do this with augmented reality interfaces. That's quite sort of standard, I guess. But then again, if you look into sort of 3D manipulation, the question is, well, what do you really measure there? Is it sort of, does it make sense to just measure task completion time, error rate? Sometimes it is, but sometimes you probably have to think about, okay, actually I want to measure different things. Or it becomes more apparent with using those new technologies. Even if it's, for example, using the Kinect, the Wii, or just and the Sony Move. Measuring task completion times and error rates probably doesn't make sense, there. Now, what you're actually more interested in is somehow the user experience. There's other things you have probably to consider when you want to do study with those types of interfaces. It's not the standard. Well, to some extent, usability questions can come in that you say, like, okay, well, we want to really find if they're more usable or not. But in the end, you'll also have other questions that could be interesting. As I said, experience with those. How do they impact on the gaming experience or not? So there's different types of research questions that that evolve with those new types of interfaces as well. And some more of those considerations. So just to give you an idea, what we were interested in, just for example, what's the status quo of evaluation studies in augmented reality? And we did a survey of a whole bunch of publications, I guess. So we collected, so we chose two databases, the ACM and the IEEE database. You're familiar with those? So these are just publication databases. So if you want to find specific publications on a certain topic, you can use those databases. The IEEE Explore database, for example, that's index a lot of different papers from different journals, from different conferences, and so you can find your relevant papers on those kinds of databases. And for augmented reality research, ACM and IEEE are, let's say, the most common ones. There are other databases as well and other publishers, but the ACM and IEEE are sort of the most common ones. That's why we chose those two. And so we did a keyword search on augmented reality, which came out sort of with, for those two databases, with around 3,000 papers. And then we went through different filtering stages. So we then did another keyword search on sort of evaluation papers within those augmented reality papers. And we found around 500 articles that could be classified as augmented reality research papers that that have an evaluation component in there. So where sometimes you find papers that just talk about technology developments, but we were interested in papers that include a evaluation component. So where the interfaces were actually evaluated in somehow. So and the next step we took those papers and classified them into different categories in terms of what evaluation approach, evaluation type and evaluation approach was taken. So the first was the evaluation type. So this was more sort of what was evaluated there in those papers. So the first category was perception, so low-level task, like perception task, and we're going to talk about sort of examples afterwards, what that means, So you would talk about sort of perceptual experiments where you, for example, flip your vision, and then your brain can adjust. So those are more sort of perception type of studies, or sort of depth perception, for example. How do different interfaces promote depth perception or not? The next category would be your classical performance and interaction studies, where you measure task completion time, error rates. So those types of studies. The third category was studies that look into collaboration and how those interfaces support collaboration between users. And again, a quick example afterwards. And studies that look more into general system design and usability.
What would you do if you wanted to test something like a musical instrument, where the qualification of how well they're done is a bit more ambiguous?
I guess depends on what you want to test. You don't want to test your musical instrument. You want to test a certain thing with it. again, that comes down to the research question. You don't. I guess you have to be sort of more specific. What it is you probably want to test there. So no, it's sort of. Otherwise, again, the answer could be 42. To some extent, you don't want to test the musical interface. You want to test something the musical interface does or provides or does better or different to another interface. And I think then it comes down what that is, and that sort of comes down to sort of you defining the research question for your study, I guess, And I don't know, we could. So what are potential things you could think about studying?
Just the user experience.
Yeah, for example, that could then be, user experience compared to something else, or just in general, if it provides any.
Well, if it's one that just wants to be usable, like the participant will actually want to use this again, sort of thing, rather than I don't want to pick this up because last time I picked this up it was a chore and I don't want to use it. It's not fun. So. Yeah.
So again, it really comes down to it could be that you're interested again. Okay, first of all, I'm interested if it's usable at all. That doesn't mean that it's sort of a pleasurable experience. The application per se, but it's at least it's usable. And another question could be then, okay, now we established that it's usable. So another question could be, well, is the user experience it provides any good? Is it any better than, I don't know, playing a real instrument or whatever? It really comes down to what you're interested in, and sort of to specify. Okay, I'm really interested in this and that, and again, to come up with some of those ideas, some exploratory study could be quite beneficial. You could say like, okay, I'll just let someone use the interface and observe what they're doing, and then debrief afterwards. It's quite exploratory. You probably won't get sort of representative results that are publishable afterwards, but you get sort of, it can inform sort of yourself and sort of in finding a more specific topic for studying afterwards.
Right. Could an exploratory evaluation ever be publishable?
Well, if it's I think in the end, yes. Well, if it's an interesting result and you make it clear that it's an exploratory study, and you say like, okay, well, we did this and we found that, yeah, sure, why not? I guess it depends on
supervisors.
Well, I guess it depends on how you can sell it. If it's sort of something really that brings basically the field forward, or just provides some new insights, provides some new knowledge, some new data.
And if that is the only way to extract that piece of data is using it.
Yeah,
that sort of
I think then that's certainly feasible. Again, no. Well, it could depend on your supervisors differently. If they and it could depend on reviewers for journals as well.
Yeah.
But that's just the part of the game in the end. And you just have to make a convincing job. Like always, it's the one part is basically what you do and your data, and the other part of it is sort of how you present the data afterwards. Well, you always should present it as it is and not try to oversell it. But it's like if you go to a movie, it's like either there's good movies or there's bad movies. No. Independent of the content, basically, So
if you're a good story writer, you've probably got a better chance. But you also need.
Well, but I think that's a fact. That's if you read a research paper, and although the contents, everything's sound and fine, but it's just not written very good. You just probably don't enjoy reading it to some extent. It's, and if someone has sort of the skill of sort of making their points, it's just a fact of life that sort of if you're good at sort of bringing selling basically your stuff, your chances are probably going to be high to be acknowledged in the end.
It's kind of like when someone says, "How's it going?" and you go, "Yeah, good," regardless of how well it's actually going, because otherwise they're not going to want to keep asking you.
Yeah.
How you doing. Just
Yeah.
tell them that the results are good, and then try and be as honest as possible.
Yeah. So I don't want to say just always try to make it better as it is. Be honest with the data. Be sort of consistent. But in the end, it's up to your writing skills as well and how your paper is perceived. Okay. So what did we find? What did we find in our survey? Well, not surprisingly, the user performance studies are the most common ones. It's not surprising, we sort of expect that as well. Because most papers, evaluation papers you find out there, measure reaction times, error rates, or some sort of performance type of measure. Because it's, on the one hand, it's one of the easiest to measure and to analyze to some extent, and most of the times it makes sense to measure that. But sort of, I think the message here is as well to try to think outside of the box as well. And there's more things you can study rather than only reaction time and error rates. So it has been done quite a lot, but there's other types of evaluation you can do. So especially with the collaboration, what we found is sort of quite surprising that not so many studies looked into collaboration. Especially with augmented reality, there's a good point of how those types of interfaces can promote collaboration to some extent, because they're just with a computer interface, with a standard computer, you sit in front of one screen with one keyboard with one mouse, have one viewpoint. It's not the best interface for collaborating. With augmented reality interface or virtual reality interface, you have sort of a different task space. It's just the different types of interfaces, different space where you can interact with. So it's a lot. It lends itself a lot better to collaboration. So it was quite surprising to find that so few papers actually looked into evaluating how those interfaces support collaboration between users.
Is it sort of like with collaboration? It's still a measure of performance in a way. Like performance between the two people?
Not so much, some look into sort of how people, so conversation between participants, sort of how, or how often they use sort of different types of communication or different types of gestures, for example. There's static gestures, where they just point towards different things, and so you can analyze how sort of how many sort of turnovers there are, so how often sort of
like modal switches or something.
What?
Like a modal switch.
For example, yeah, exactly. Or how often, if there's one person sort of being dominant, or if there's sort of equal amounts of communication between people. So it's more of looking into patterns of communications, patterns of gesturing, and those type of things can be are sort of common for those types of evaluations. So for sort of what kinds of measurements were taken there? Sort of there were objective measurements, the most common ones again, like reaction time. Subjective measurements that are sort of, for example, questionnaire type of items. They were sort of the second most common type of evaluations that were done. Qualitative studies were not that common. Usability type of evaluations, where it is purely usability and didn't include any other types of measures, were not that common as well. And I guess one of the reasons is, that a purely usability results is probably not that interesting from a research perspective. If you say like I came up with this idea and it's a usable idea, it not necessarily brings the research field forward. You want to measure something, you want to have sort of potentially different research questions, and not just purely it's a usable product. that's more interesting for if you want to sell a product, then you want to find, okay, it's a usable product, users will actually enjoy doing that. But for research type of question, well, from a research point of view, usability per se is not always the most important or most interesting research question. And there were quite a lot of informal evaluations. And what I call informal evaluation is basically those, well, as the name says, not formal evaluations, where it's just we gathered some feedback, and then authors report on that feedback. And
That's publishable.
Unfortunately, yes. It's probably getting a little bit more sort of strict. Hopefully, now that it's sort of that reviews are a little bit more specific about sort of the quality of the evaluation that it has to be done. But unfortunately, you find it quite often. That people just report on, yeah, we presented our demo somewhere on a conference. Asked people how they liked it, or just get some feedback, and overall they pretty enjoyed it. Yeah, and I think you can make up your own mind of sort of the quality of those results in the end. But the research environment is not perfect, and you see those results out there.
I'm just amazed it's possible. It seems like a real easy way.
I think it depends as well on the venue and probably on the quality of the papers in a specific conference, or not for all conferences you have to submit the most highest quality papers. It depends. Some conferences have sort of high quality papers, some have sort of low quality papers in there. We were quickly talking about this, I think last time, sort of a quick note on sort of measurements. So we're talking about sort of objective, subjective measurements. So in the end, a measurement is basically every observation you gathered and somehow noted down somewhere. That sort of constitutes a measurement. How you do that? That's another question. So a measurement is a recorded observation. So what are typical objective measurements? Well, those are those measurements like task completion time, error rates, percentage of tasks completed, number of repetitions. So something objective you can measure in the end. And so this is just a list of typical objective measurements that are used in HCI research. So on the other hand, what are subjective measurements? Well, subjective measurements are rating scales, questionnaire items, judgments. We have to ask people to do to make sort of depth judgments, for example. These are subjective measurements because they are sort of depend on the subjectivity of your participants. They make sort of a subjective judgment about a specific item. So if you ask them, did you like it? They can say like, well, yeah, I liked it, or I didn't. So that's a subjective measurement of the enjoyability, or sort of how people liked your interacting with your interface. So for qualitative analysis, we're going to talk about this in more detail in another lecture. So it's not what we were talking about, sort of the informal, just gathering feedback. So there's a whole process to it, and so you gather your data quite formally, and there's different ways of doing that. But we're going to talk about this in more detail in another lecture. And also we're going to talk about the usability evaluation techniques in another lecture in more detail. So again, the main reason there is for doing this is to find questions about, well, as the name says, the usability of your interface, and there's certain aspects to it, like learnability, ease of use, and those types of things. But we're going to talk about these questions about sort of usability evaluation in more detail in another lecture. Oops. Probably sneaked in some. Well, in this case, some of those are non-user based actually, and that's what I wanted to make the point in our in the survey we did. We only classified a study as a usability evaluation when it didn't include any users. So that might surprise you, I guess. Just to give you a quick idea what that means. Well, some usability evaluation techniques don't use actual end users, but for example, experts who do heuristic evaluations. So you and I would call this non-user based because you're not dealing with end users, but with specific sort of expert users, and they are not using you don't give them tasks to go through your sort of not necessarily you give them tasks, representative tasks to go through but you ask them about their expert opinion on your interface, and they can go through sort of known heuristics and then give you their expert opinion about the usability of your interface. So that's why I would call them sort of non-user based. Or those things like cognitive walkthrough sort of would be summarized there as well as non-user based. And those informal evaluations we talked about, also like those quick and dirty informal feedback. It can give you some feedback. So we talked about sort of they can give you some information for yourself, I guess. It's just some on initial or early stages. You just give your interface to, for example, a colleague or someone, to just ask them, okay, can you just give me sort of quick feedback of what do you think about my interface? That's during your design of your interface, but not as a final evaluation of it. So it can give you some valuable results if you do it at the right time, if you use it as it's sort of supposed to be used, I guess, as sort of get quick input for your design.
So it's kind of like, because we're studying the design process, but you have the lo-fi prototypes and stuff like that. So.
Exactly. Well, and you probably don't want to run a huge full-blown study with your sort of early prototypes of your lo-fi designs. So there, sort of those informal evaluations can give you some sort of feedback. Am I on the right track? Just give sort of early input from someone else to to inform your future or to your ongoing design. Yeah, for those types of things, sort of informal evaluation can be quite valuable, but just be aware that it's not. You won't get generalizable results. They are not, and you won't get necessarily publishable results out of your informal evaluation. So quickly, some examples, because we have to sort of go to the next to our participants then as well. I'm just going quickly through the examples. If you want to have a look in more detail, we have the references to those papers on the slides as well. So did you have a look at those papers if you want to have a look at those papers in more details. So this example looks at sort of perception studies. So those guys had sort of different displays and looked sort of how those display conditions worked for perceiving people being able to read text from different backgrounds. So they have had several hypotheses, and they use quantitative measures. So like they had sort of to identify targets out of those letters. So they have to find sort of where they could find sort of two V's behind each other. They measured response time and error rates, analyzed the data with sort of analysis of variance. So your classical, that would be one of the classic HCI experiments for augmented reality. Objective measurements, you have your analysis of variance. So that would be one sort of classical papers that you find quite often out there. The next example looked into subjective measurements. So people were asked, so you had sort of a phantom haptic feedback device, and sort of they studied effects of sort of visual and haptic feedback on the perceived stiffness of a spring. And so the participants, as you see here, had to press basically a virtual button, with a sort of a virtual stiffness, or with different stiffness, and had to make sort of subjective judgments on which one they perceived sort of as stiffer and as not as stiff. So just to give you an idea of different types of metrics and measurements you can use. So those guys measured, for example, just noticeable difference between two different interfaces, and then came up with their results based on those measurements. And again, for the results, have a look at the paper to sort of give you more a better idea about that. So this is one study I was involved with, where we looked into using a augmented reality based interface. Well, it was teaching geometry education, and we were interested in does a training with this type of interface have a positive effect on spatial ability? So we did a sort of a bigger study with overall sort of over 200, almost 300 high school students in the end. We had 4 experimental groups. So one used the augmented reality interface, one used the desktop interface, and 2 had just regular geometry education classes in school. Our measurements basically was a pre and post test with those typical spatial ability measurement tools. So these are spatial ability tests, quite commonly used in psychology, to measure spatial ability in students or in people. So we had students complete a set of those tests beforehand, then they had the training, and then they had to complete another set of those spatial ability tests afterwards, and we measured sort of if there was a difference between pre and post between the different experimental groups. Well, we used a mixed model analysis of variance because we had a within, pre-post factor and a within factor, which were the 4 groups. Well, there were no clear results, to make it short, I guess. Again, more details you will find in the paper. Sort of there was just some problems with the measurement tool in the end as well. This is one example we were just talking about, sort of about a study done by Mark back in the days, where they looked into how those sort of an augmented reality interface can support collaboration. So this is one of the few collaboration studies that's sort of out there. So what they used as measurements, because we were talking about this sort of communication measures, as we were talking about, sort of they used the video recording, transcribed the video, and then analyzed the number of gestures, the average number of words spoken per participants, and the number of turns in the conversation, for example. Again, these are just examples to give you ideas what kinds of research have been done for those, especially augmented reality interface, but could probably inspire you as well in finding sort of interesting research questions or ways of studying your research in the end. Again, task completion time as well, analyzed with analysis of variance. So this is quite common in HCI research. Sort of a more qualitative approach was taken by Morrison and colleagues. So they compared 2 different interfaces, just a map on a mobile device, just a regular map on a mobile device, compared to a AR interface, where you could sort of see virtual information overlaid on top on a physical map, and they compared those 2 interfaces in a field study where they had sort of groups of people using those interfaces in the field, and they had people running behind them with video cameras, and where I had the pleasure to be one of the experimenters as well, and sort of then used those video observations afterwards for analysis. Well, they also used sort of some kinds of triangulation of results. So it was not just the qualitative analysis of the video recordings, but they also had some questionnaires in there as well. So they tried to combine those different results to come up with sort of their conclusions. Another example is a sort of a usability study using qualitative analysis, and in this case, sort of they investigated sort of the user experience acceptance of using AR interfaces in a medical setting, and so they were more interested sort of, is it something that doctors would find sort of usable and acceptable, an AR type of interface in those settings. Again, to give you an idea about sort of how those types of studies can be done, you can refer to this paper. And I think, is it this the last one? Probably not. So another example is, oh no, that's the same one. And this is quite a nice example as well of a study where the researchers went through sort of a whole basically cycle of different studies, and that's, I don't know if you talked about this in the first lecture with Mark or with Rob about sort of cycles of doing studies. You know, it's not just that you do necessarily just one study in the end when you have the finished product, but you know, we just talked about earlier, you know, it's probably a good idea to make sort of several studies along the way, and sort of there's different studies you can do at different stages, I guess. And this is quite a good example of this approach, I guess. So first, those guys did just the user task analysis. So what's you know, what kinds of tasks would users do in a certain scenario? Then they had sort of I think several cycles of expert-based evaluation of their early prototype. And then they did sort of a formative user-centered evaluation afterwards. And I think they just were missing off sort of the last step in their proposed model. So that's their proposed model of sort of what they plan to go through. I think the paper doesn't talk about the last sort of the comparative evaluation of their system to another one. But otherwise, it just gives a good example of sort of how you can go through sort of a whole cycle of different types of studies in your research. So have a look at this paper as well if you're interested. Gives you some good ideas. So again, we have here all the references to those papers with some links as well where you can find them. And so I'd sort of recommend that you have a look at those papers to give you just a better idea of sort of the field of sort of evaluating, especially augmented reality interfaces. But you can sort of learn your lessons for all other kinds of new types of and emerging technologies, new types of interfaces as well. I think because the evaluation approaches taken there are most likely adaptive for all other types of emerging interfaces as well. So we've finished with those sets of slides. We can have a sort of quick break probably, or should we just dig through with some, starting with the participants?
Keen for coffee.
Keen for coffee? Probably just a quick one for 3 minutes because we're just short on time. Okay. So just let's talk a little bit about participants, and we started sort of some topics already, I guess. So it's sort of questions that could arise. Sort of well, how do I find participants? Who are my participants? How many do I need? And so treating them right then as well. And those are some topics we're going to talk about here. So, identifying participants. So how do you find participants? And so I think we talked about those issues as well already. So but depends, I guess depends on what the goal of your evaluation is. Again, we talked about sort of sometimes it can make sense to look for experts in the field. Sometimes it can be useful to only recruit novices. At other times it can be, well, again, depends on your question, can be good, or just to recruit people from the general public. It depends on your question and what you want to do with the results and how you want to generalize the results afterwards. If you run a study with experts because you're dealing with a quite advanced interface, that's fine. Just be aware of the sort of the implications afterwards. You can't then generalize the results to. We found that end users will find my new interface a lot easier, whatever. No, you can't make this call afterwards. Just be aware what this entails. So in the end, I think sort of there's a lot of different factors that influence the suitability of certain groups of participants for your study. Well, goals of your study, background of sort of the participants, in terms of expertise, age, gender, their motivation as well. Are they motivated to participate or not? If you only have people who are not motivated in participating, the results probably won't be as sort of high quality, probably. You might get people who just, if you have to, have a reaction time experiment, whatever, who just click somewhere because they just can't be bothered. So that's something to sort of consider as well. Well, sometimes none of these factors, or not all of these factors, have an influence of your result on your result, but just be aware of them and try to ask sort of just some demographics as well. So especially if you believe that there's potential influences of gender, of age, of expertise, of for example, color vision or depth perception. Ask those questions before running the study, or well, you could ask them even afterwards. But for example, if you have concerns, if you do a depth perception experiment and you ask the question only after the study, you might find that someone has sort of problems with depth perception, but they already participated in your study, and so you can check out the results. So sometimes just ask those questions and be sure that you sort of get this information. And also report those issues in your research report afterwards. You should give sort of the reader a very good idea of, what kind of population is it I want to test? What kind of population did I actually recruit from, or from which population did I recruit my sample for my experiments? And is there a match or is there no match? And sort of just report those issues in your research report. Again, what kind of whichever kind of research report you have, but just report it to give the reader a good idea of the sample as well. Because again, if you test some a new learning device for preschool children, but you tested it in here at the lab with only your mates and colleagues, you probably won't get very representative results for that.
I think there's a case in the assignment on that. I can't remember which scenario it was.
Probably, yeah. I think so. Yeah, I saw it somewhere there. But in reality, actually, is that a lot of studies, and that's not just in HCI, especially in psychology as well, is a lot of studies get in a lot of experiments, the experimenters recruit students from your discipline because they're just the easiest, And most of the psychology studies, are done with psychology students, And in the end, sure, it can be valuable, but you should just make clear in your paper afterwards to report on that the reader can make the sort of a decision as well. See, like, if they believe that this was a representative sample or not.
You don't want to leave it to the last part in your discussion, though, to say that. Wouldn't you want to say it, like, as part of the...
There's sort of a structure. There's a structure of normally you go through when you write up your results. Or with a paper for that matter. You sort of go introduction. In an HCI, you most of the time go through related works. Then you go to the method section, and in the method section, you would have a subsection on your participants. How many, some demographics. How many males, females, age, for example. How you recruited them. They're sort of probably about their experience and expertise as well. So there's always a subsection on participants, and that's where you present basically your sample. And you can then, in the discussion, certainly discuss how your sample might have influenced the results. If you have any suspicion on you say like, okay, most likely the results are this and that because my sample was not representative or whatever. That's then in the discussion to discuss afterwards. Well, I guess in the end, each study is representative, but the question is representative for what? It's representative basically for the sample you had in your study, and that's so again, if you tested HitLab people, it's most likely representative of, well, at least HitLab people and probably of, well, let's say masters and PhD students in New Zealand, but it's not necessarily representative for the wider public. Just be aware of those things. So there's different ways of recruitment and of sampling. So the most broad approach would be random sampling. So that means that every member of the population has the same chance of being selected. Doesn't happen that often, but that's sort of I guess the broadest approach. So if you're interested in generalizing your results to the general public, I guess that's sort of the standard, or that's the way you wanna go. Well, representative sampling would mean, well, you specify your target population, and then well, you certain kinds of users, expert, novices, preschoolers, psychology students, human interface technology students, whatever. So you define your ideal sort of your population, and then recruit your sample out from this population. And sort of the other way of what's called convenient sampling, that's what happens most of the time, and that was what I was talking about. If you yell down the hallway and say like, who wants to participate in my study, and wait for your colleagues to trot in, that's convenient sampling. Or even if you send out an email here in the lab, no, I have to run this study, who is willing to participate? That's in the end convenient sampling as well. It's the most convenient way, but just be aware of how the sample and how your recruitment strategy influences, or could have a potential influence on your results and on the generalizability especially. Sample size. Well, that's always an interesting question, and one of the most I get sort of asked most of the time, I guess. If people seek for advice about the study, most of the time it's not, sometimes it's what should I study, but most of the time it's like, how many participants do I need? Because in the end, most people want to hear, well, not that many. Well, because it's effort, to recruit people. Well, in the end, it's not that easy, and it's not a straightforward answer. You find sometimes this rule of thumb in HCI for about sort of 15 to 20. And, well, it's a rule of thumb to go by. It was like, okay, well, if I don't have a better idea, go at least for, let's 15 or 20. I would say always aim for more. Not the sky's the limit, because there's sort of certain problems with that as well. But you most likely won't get into problems of having too many participants in your study. So I have hardly found an HCI paper ever that had too many participants in their study. That just doesn't happen, I guess. So as a rule of thumb, fair enough, go with 15 or 20, but just be aware that's per condition or per cell, how I put it. So if you have a between subjects design, you have two groups, you have 15 or 20 per group, and not as your overall sample. If you have three conditions, that's 15 or 20 per condition, so that's 60 people overall. So just be aware of that. So if you have a between subjects design, the number of participants can multiply quite easily. And it's not good enough that you say like, oh, there's this rule of thumb, I should use 15 to 20 people, and just go for a between subject or factorial design with I don't know how many between factors. That doesn't really work out. You need at least a 15 to 20 per condition or per cell. Again, the whole question of sort of sample size, it depends on different factors. So one factor is certainly what you actually intend to study and what effect you want to study, or which effect you basically assume there is, or what effect in terms here, for example, the difference. If you study a phenomenon where you expect a huge difference between the groups, you won't need that many people to find this effect. If, on the other hand, your expected effect or difference between groups is rather small, you have to have a bigger sample. So just one example, if you want to test sort of the speed difference between a jumbo jet and a propeller plane, you probably don't need 100 jumbo jets and 100 propeller planes to come up with an idea about sort of, okay, probably in reality, well, there might be a speed difference between those two types of planes. But then if you want to find sort of, is there sort of a speed difference between different designs of the same jumbo jet design, between 747s of service, different years, whatever, you might need a bigger sample to sort of to come up with an idea. Okay, well, there might be a sort of a difference between those production runs of those types of jumbo jets. And there's sort of more practical issues as well. We talked this morning about sort of outliers. Well, effects of outliers are a lot stronger the smaller the sample size is. So if you have a sample of 20 people and there's one outlier, this outlier won't have such a big influence on the results compared to a sample of, let's say, 5 participants. With 5 participants, one outlier, this outlier will have sort of a whole sort of a bigger effect on your mean, just skew it somehow, than if you have just a bigger sample. So with a bigger sample, you just get rid of the noise more easily in your data. It's just noise gets sort of evened out, and sort of the variability between your participants gets sort of evened out as well. So there's a lot of sort of arguments, I guess, for sort of just trying to have a big enough sample for studying your research question. If you want to make sure sort of to calculate the optimal number of participants for your research, you can do a power analysis. So there's a link to a free tool that you can use where you can put in your numbers and then find the ideal number of participants. It's not that often done in HCI, so I haven't seen it very often. It's more common in psychology research and very common in medical research. So for most medical papers, and especially if you have sort of putting grant applications for medical research, there's always has to be a power analysis there to calculate your optimal or your ideal number of participants. So what do you need? So you need your alpha. We talked about sort of the alpha level. That's the risk, sort of the risk of doing of your type 1 error. You need the beta. That's your risk of type 2 error, and 1 minus this beta. That's the power of your test. So that's the probability of observing the difference when really there is an effect. And you need this delta, and that's the effect size. So that's the effect you expect there to be. And so that's what I was talking about. If you expect this effect to be big, then your required sample size would be smaller. If you expect the effect to be small, then your required sample size would be bigger. The difficulty is basically to come up. Well, alpha is basically set anyway. You set alpha most of the time at 5%. With beta, there's you most of the time set this at 80%. This is just a general way of doing it, and there's sort of those. You can read about that sort of in more detail, but that's sort of more sort of the common ways of setting those parameters. But there is no ideal way of determining the effect size, and that's one of the problems of sort of why the power analysis is not done that often. And basically that comes out of your research and out of ideally prior research, of your background research. But the problem is in HCI effect sizes are not reported that often. You don't find it that often that somebody reports the effect size as well. So that can be one of the difficulties to come up with a good idea about the effect you expect, and that's sort of one of the difficulties there, to come up with sort of a good idea about the expected effect size. But if you have it, by all means, give it a try. The other issue you will find that most of the time the results will be, well, disappointing in a way that it's that they show that you need a bigger sample than you expected you would need. So most of the time, which is suggest more than the rule of thumb we had in the early slide of 15 to 20. Most of the time, it's this required sample size would be a lot bigger. But basically, it tells you, okay, if you have a sample size, if you have a sample of that size, that's of the result of your power analysis, you can be confident, or sort of confident that if there is, well, more confident that if there is a statistical significant effect, that you will find it with your analysis. What you find quite often in ACR research in the discussion, say like, oh, we didn't find a significant result, but that might be due to our small sample size. Well, in the end, you should actually, as a reviewer, it's just like, well, yeah, sure, but you knew that before that your sample size is probably too small. You could have run a power analysis and identified your ideal number of participants. It's sort of sometimes a little bit of sort of a cheap excuse afterwards to say like, okay, we didn't find a significant result, but that might be just due to small sample size, and next time we will do it could Well, in the end, you could argue, well, you could have done it better in the first run, and then just get sort of more just better results in the first place. It also depends on the type of study you conduct. We were talking about sort of this whole idea of power analysis and effect size, whatever. No, that comes in if you do quantitative research. If you want to do statistics, do quantitative research, then you can you run your power analysis, and in those considerations come into effect. If you, on the other hand, you run qualitative research or ethnography studies, case studies, it's sort of it's a different matter. You don't need that many participants for those types of studies. For qualitative research, your main goal is not necessarily to generalize your results to sort of to the bigger population, but you want to find sort of a more you're interested in analyzing the quality of for example, the user experience, or how someone interacted with your interface. And for that, you need sort of fewer participants. And just from a practical point of view, with qualitative or ethnography types of studies, you can't run big samples because they're a lot more time consuming to gather the data and to analyze the data afterwards. And for usability studies, that's one point of sort of misunderstanding quite often as well, because people just argue, oh well, I read Nielsen, and Nielsen he's sort of the guru for usability and especially web usability, and he has his own column, and he's one sort of very well-known author, and he published this book and sort of several articles as well, where he argues that you only need 5 users for your heuristic evaluation, and so you only need 5 experts to uncover 80% of usability problems, which is fair enough, yes, but a lot of people just misinterpret that as I only need 5. I don't only need. Nielsen said I only need 5 participants in my research study. No, that's not what sort of this is all about. So for your usability study, what you're interested in is finding major sort of problems with your interface, usability problems with the interface. And that's fair. And you don't need a lot of people to find major problems with the interface. You probably don't need 20 people to find major navigation issues with a web page. You only need, as sort of as Nielsen argues, probably 5 experts or 5 users to find the majority of major problems. And he argues that rather than doing one study with 20 people, do multiple sets of studies with 5 people each. And that's fair enough for usability type of studies. It doesn't apply to research studies that sort of follow sort of a quantitative research and analysis approach. So they certainly need more than 5 people.
The 2 completely different studies almost. The
Yeah,
usability
definitely.
studies pretty much purely to identify flaws in the interface,
Exactly.
whereas the other ones you're trying to experiment or find something.
Exactly. Yeah. It's different types of different types of questions you want to get an answer to for those with those studies.
So like one usability expert would probably find like 50%, and then like as you get more and more it'll plateau off. So like
Exactly.
like 20 people might find 90%.
Exactly. Yeah. And that was Nielsen's argument, and he basically plots this graph. Where we find, okay, sort of 5 people now have the 80%, and then the additional gain through sort of having more experts in there it's not sort of proportional. So he argues just make several smaller studies with those experts, and that just helps you for the next iteration to find use again 5 experts to find sort of additional other problems with your new design. Exactly. Yeah. So other factors to consider is sometimes it's very hard to find suitable participants. If you want to recruit from the general public, it's not that difficult. But if you have specific users in mind, it can get a lot more difficult. If you need experts in augmented reality interfaces, it's can be challenging to find a big sample of AR experts in New Zealand. We had another a student who looked into using virtual reality for rehabilitation, cognitive rehabilitation for stroke patients. And he had a very hard time to find a big enough sample here in Christchurch. So because he needed people with stroke or traumatic brain injury. And so he had a very difficult time to find enough people for participating, who would participate in his study. And in the end, he was from Germany and had sort of contacts there, so he went back to Germany to conduct his studies over there in a rehabilitation clinic. So so those factors can certainly have an impact on sort of participant recruitment. Also, so the time required for each participant. If you have a study that requires 1 day per participant. You know, you can't recruit 100 participants because that just would take a considerable amount of your time as well to run this study. And well, the purpose of the study as well. You know, if you do a usability study or a pilot study, you don't need that many people. So I guess we again ran out of time. So we have some more things. We just were quickly talking about earlier about ethical issues. So these are some things we're going to talk about next time, about ethical issues, how to handle participants, and about the Human Ethics Committee. There's some issues we haven't talked about today that come up in the assignment, but I'm pretty sure you should be fine because one item of the assignment will be to write an example informed consent form, and there's some. So we haven't talked about this today, but there's enough information either on the slides or in the book to give you some more information about what should be in a consent form. Have a look at the University of Canterbury Human Ethics Committee website. In one of the slides are online. In one of the slides there is a link to the Human Ethics Committee at the university, and they have some information there about the Human Ethics Committee process here, and we're going to talk about this then to just recap that the beginning of next lecture then as well, and answer some open questions. If you have any issues or problems with the assignment, then just come and ask. Okay, thanks. And next lecture then at 10 o'clock next Tuesday. Okay, thanks.